on our chemistry syllabus. The revision will be based on the new system, the booklet system. You know that the booklet is short answered questions. So we have to try to answer some questions based on this new system. Choose the correct answer of the following. The highest oxidation number of any element of the first transition series cannot exceed its group number except the element of group. Our choices are group 1b, group 2b, group 3b, and group 5b. The answer is group 1b because it has an oxidation number +1 or +2 in some cases like copper, or +3 even in gold. An alloy is used with iron in manufacture of railway bars. We have different choices: chromium, manganese, cobalt, and HCl. Of course, the answer is manganese. The iron manganese alloy is used in railway bars. The compound FeCl3 is paramagnetic colored, diamagnetic colorless, diamagnetic colored, or paramagnetic colorless. Fe is +3, so we have 5 ampered electron. The 5 ampered electron will give us a paramagnetic and colored compound. In this question, we have the following figure. This figure expresses the activation energy of chemical reaction before and after using a catalyst, from which we can deduce that the activation energy of catalyzed reaction equal how many kilojoule per mole. If we see 130 is the energy of the reaction, the activation energy of the reaction without using catalyst. 180 and 210, from these two numbers, we can deduce that the difference between the activation energy in case of using catalyst and in case of without using catalyst, the difference is 30. So we can deduce 30 from 130 to know the activation energy of the catalyzed reaction. We have 4 answers: 180, 130, 100, or 50. If we deduce 130 minus 30, it gives 100. On heating iron to oxalate in absence of air, then treating the solid product with diluted sulfuric acid, which compound is formed? Iron 2 sulfate and water, iron 2 oxide with carbon dioxide and carbon dioxide gases, iron 3 oxides and carbon dioxide gas, iron 2 sulfate, and water. When we heat iron 2 oxalate in absence of air, it decomposes thermally, giving iron 2 oxide. So when iron 2 oxide reacts with the acid, it gives iron 2 sulfate and water, a salt, iron 2 with water. Copper is used in the manufacture of all of the following except coin alloys, Fehling solution, aircrafts, or bronze alloy. The answer is aircraft, because copper is a main component of the coin alloy, main component of Fehling solution, and also in bronze alloy. Let's move to another kind of questions. Write the scientific term. A solution used to detect glucose solution. This is Fehling solution. The process of immersing steel in molten zinc to protect steel from corrosion. This process is called metal galvanization. Protein molecules that act as catalysts in biological processes. These protein molecules are called enzymes. Increasing the percent of iron in its ore by separating the impurities using the surface tension property. This is what we call concentration and purification of iron ores. A transition element, very active chemically, but it resists the effect of atmospheric air. This is chromium. The process of treating fine iron ore to obtain large particle suitable for reduction process. This is what we call sintering process. Another kind of questions give reason for the following. Elements of first transition series are used as catalysts in industry. This is due to the presence of unpaired electron in the orbitals of the d sublevel, which are used in the formation of bonds between the atoms of the surface and the reacting molecules, leading to the increase in the concentration of these molecules on the surface of the catalyst. So the reaction goes faster, increasing the production and decrease the activation energy of the reaction. Zinc is not considered from transition elements. This is because in their free state, the sublevel D will be completely filled with D10 electrons, as it has an electron configuration of argon 4s2 3d10. And also, in their compounds, their oxidation state is always positive 2. So the sublevel D will be completely filled with D10 electrons. So they are not considered as transition elements. Titanium is used in implantation of teeth and joints. This is because it is inert substance, not ejected by the body and not poisonous. Iron does not react with concentrated nitric acid due to the passivity effect of iron, as concentration of concentrated nitric acid, which is a strong oxidizing agent, it will oxidize the outer atoms of iron fillings, forming a non-porous layer of the metal oxide that prevent iron from further reaction with the acid. Compare between the reduction of iron ore in the high furnace and its reduction in Midrex furnace. In high furnace, it takes place by using the reducing agent carbon monoxide gas, which is obtained from the coke. Hematite Fe2O3 reacts with 3 carbon monoxide to give 2 iron with 3 carbon dioxide gas. While in Midrex furnace, it takes place by using the reducing agent water gas, which is a mixture of carbon monoxide gas and hydrogen gas obtained from natural gas. So 2 hematite molecule to Fe2O3 reacts with 3 carbon monoxide and 3 hydrogen, which is the mixture called water gas, to produce 4 iron plus 3 carbon dioxide and 3 water molecules. Compare between paramagnetic substances and diamagnetic substance. A paramagnetic substance is a substance which is attracted to the magnetic field due to the presence of unpaired electron in the d orbitals, while diamagnetic substance, it is a substance which is repelled from the magnetic field due to the presence of all paired electrons in all of the d orbitals. the magnetic momentum of paramagnetic substance equal to the number of unpaired electrons in the d sublevel. For example, iron, which has an atomic number 26, its electronic configuration ends with 4s2 3d6. So it has 4 unpaired electrons. While in a diamagnetic substance, the magnetic momentum is always equal 0, as zinc, which has electron configuration ending with 4s2 3d10, so it has a complete d orbitals and no unpaired electrons is found. What's meant by the following? Complementary color. It is a color which is not absorbed by the substance. Substitutional alloy. It is the alloy that is formed when some atoms of the crystalline lattice of the pure metal are replaced by the atoms of the metal added. The introduced atom must have the same diameter, the same chemical properties, and the same crystalline structure. Illustrate with balanced equation the following reaction. The reaction between iron with diluted sulfuric acid and its reaction with concentrated hot sulfuric acid. Iron, when it reacts with H2SO4 diluted, iron replaces the hydrogen, forming iron 2 sulfate FeSO4 plus hydrogen gas that evolve. While its reaction with concentrated hot sulfuric acid, it gives the two salts, iron 2 sulfate and iron 3 sulfate, with 8 water molecules and evolution of sulfur dioxide gas. The effect of heat on siderite. Siderite is iron 2 carbonate, so 2FeCO3. By the effect of heat, it decomposes into iron 2 oxide FeO and carbon dioxide gas evolve. Illustrate with balanced equation how to obtain the following. Iron from iron 2 sulfate. Starting from iron 2 sulfate, by the effect of heat, it decomposes into iron 3 oxide Fe2O3 plus sulfur dioxide gas and sulfur trioxide gas. Then, the iron 3 oxide that we obtained, we can react it with carbon monoxide gas to reduce it completely, producing 2Fe plus 3 carbon dioxide. So, we had obtained iron from iron 2 sulfate. Another one, iron 3 oxide from iron 2 oxalate. By heating iron 2 oxalate in absence of air, it decomposes into iron 2 oxide FeO plus carbon monoxide with carbon dioxide gas. Then the FeO, iron 2 oxide we had obtained, can be oxidized to produce Fe2O3 iron 3 oxide. Mention one of use of each of the following. Titanium dioxide. It is used in manufacture of the sun protection cosmetic products. Vanadium pentaoxide. It is used in the manufacture of dyes used in ceramic and glass industry, also as catalyst in the manufacture of highly magnetic conductors. Mention one use of the following. Scandium. Scandium element is added to mercury vapor, light bulbs, to produce high efficient light similar to the sunlight. This is used in television photographing during night. Nickel chromium alloy. It is used in heating coils in electric iron and electric furnaces. Mention the rule of each of the following. Coke in high furnace in iron extraction. Coke is used to prepare the reducing agent in the blast or the high furnace, which is carbon monoxide gas that is used to reduce hematite into iron. This is done as the following equation. Carbon, which is a coke, reacts with oxygen in presence of heat to produce carbon dioxide gas. Then carbon dioxide gas, it reacts with more coke to produce carbon monoxide gas. This is our reducing agent in the blast furnace. So hematite Fe2O3 is reduced with 3 carbon monoxide gas to produce 2 iron and 3 carbon dioxide. What is the role of natural gas in Midrex furnace? Natural gas is used to prepare the reducing agent of the Midrex furnace, which is a water gas, a mixture of carbon monoxide and hydrogen gas, which is used to reduce hematite into iron. Let's see these equations. 2-methane gas, which is a natural gas main component, plus carbon dioxide plus water vapor, it produces 3 carbon monoxide with 5 hydrogen. This is a mixture of water gas. Then hematite Fe2O3 is reduced in presence of water gas carbon monoxide with hydrogen gases to produce 4 iron, 3 carbon dioxide gas, and 3 water molecules. Classify the following. Classify the following alloys into intermetallic alloys, substitutional alloys, interstitial alloys. We have 4 alloys: aluminium nickel alloy, iron carbon steel alloy, cementite alloy, and iron chromium alloy. The intermetallic alloys, we have aluminium nickel alloy and also the cementite alloy, while iron chromium alloy is a substitutional alloy. The last one, iron carbon steel alloy, is interstitial alloy. Let's compare between the following: the fuel cell and the lithium ion cell. We start with our comparison with the type of anode. In the fuel cell, the type of anode is hydrogen gas, while in lithium ion cell, it is lithium graphite. The cathode type. In the fuel cell, the cathode is oxygen gas, while in the lithium ion cell, it has lithium cobalt oxide. Also, the kind of electrolyte. In the fuel cell, the electrolyte is hydrated potassium hydroxide, while in lithium ion cell, the electrolyte is anhydrous lithium phosphorus hexafluoride. The chemical reaction in both of them. The total reaction in the fuel cell is 2 hydrogen plus oxygen. It's a primary cell, so it is in one direction. It gives 2 water. While the total reaction in lithium ion cell, LiC6 lithium graphite plus cobalt oxide COO2. In a reversible reaction, because it is a secondary cell, it gives C6 and LiCOO2, lithium cobalt oxide. This is a discharge reaction, and the backward is the charging reaction. Let's compare another comparison between anodic protection and cathodic protection. The anodic protection. The protective element is more active than iron, while in the cathodic protection, the protective element is always less active than iron. In the anodic protection, the protective element acts as anode, while iron acts as cathode. It is a reverse in cathodic protection. The protective element acts as cathode, while iron acts as anode. So, in the anodic protection, the protective element is corroded first, while corrosion of iron is delayed for a long time. For example, using magnesium to cover the iron bodies of ships or iron pipes in the soil. While in cathodic protection, the iron is corroded first, especially when the protective layer is scratched. For example, using tin to cover iron in the cans. Let's have a problem. An electroplating process is carried out for a plate of copper having an area of 100 centimeter square with a gold layer using quantity of electricity equal half a Faraday by an aqueous solution of gold 3 chloride. Calculate the thickness of the gold layer precipitated given that the density of gold equal 13.2 gram per centimeter cube. First, we can calculate the mass of precipitated gold. The law says that the quantity of electricity in Faraday, which we have a half Faraday, times the equivalent mass of the element gold, which is 196.98, divided by its valency, which is 3, as we have a solution of gold 3 chloride. So the mass will be 32.83 gram. Then we have the law of density. Density equal mass divided by the volume. We have the density and we have the mass. So the volume, we can calculate it by dividing the mass by density. The mass we have got is 32.83 gram, while the density of gold is given as 13.2. So the answer is 2.487 centimeter cube. We know the volume is a 3-dimension measurement, while the area is 2-dimension measurement. So the thickness, which is the height, equal to the volume divided by the area. The volume we calculated before, 2.487 centimeter cube, while the area is given 100 centimeter square. So the thickness equal 0.02487 centimeter. This is the thickness of the gold layer precipitated on the copper sheet or the copper plate. On passing the same quantity of electricity in two cells connected in series, the first one contains silver ions, while the other one contains gold ions. The mass of the precipitated silver in the first cell was 2.158 gram, while the mass of the precipitated gold in the second cell was 1.314 gram. Find the oxidation state of the gold in the second cell, given the atomic mass of gold is 197, while of silver 108. To calculate the oxidation state, we want to know the valency of gold in the second cell. So, as we know that the mass of the deposit substance equal the quantity of electricity in Faraday times the equivalent mass of a substance, so we have the mass of gold, 2.158 gram of the silver. So it equal to the quantity that pass in the two cells connected in series times the equivalent mass of silver, which is equal to 108 divided by its valency, which is monovalent. So we can calculate the Q, the quantity of electricity in Faraday passing in the two cells. It will be 0.01998 Faraday. So we can use the same quantity of electricity in the second cell, as the mass of the deposit substance equal the quantity of electricity in Faraday times the equivalent mass of a substance. We can apply this on the gold, which is precipitated, which equal to 1.314 gram, equal to the quantity of electricity we calculated before, which is 0.01998 Faraday, times the equivalent mass of gold. We know that its atomic mass is 197, but we don't know its valency. Let's assume it's X. So the X, which is the oxidation state or the valency of gold, equal to 2.995. Approximately, it's 3. The oxidation state of gold is positive 3. It's trivalent. A sample of a mixture of sodium hydroxide and sodium sulfate, its mass is 1 gram, is dissolved in water. Then it is neutralized with 20 milliliter of sulfuric acid. Its concentration is 0.2 mole per liter. Calculate the percent of sodium hydroxide in the mixture. From the volume and the concentration of sulfuric acid reacted, we can calculate the number of moles of reacted sulfuric acid. 0.2 molar solution times 20 milliliter, which is the volume, divided by 1000 to convert it into liter, it gives 4 times 10 to the power of negative 3 moles. This is the moles of sulfuric acid reacted. And the equation will be H2SO4 plus 2 moles of NaOH to produce sodium sulfate and water. This means that 1 mole of sulfuric acid react with 2 moles of sodium hydroxide. So when 4 times 10 to the power of negative 3 moles of the acid react, it gives X moles of sodium hydroxide. By cross multiplication, we can calculate and find the number of moles of sodium hydroxide, which will be 8 times 10 to the power of negative 3 moles. Then we can calculate its mass by multiplying the number of moles times its molar mass. So the mass of NaOH will be 8 times 10 to the power of negative 3 times the molar mass of NaOH, which is 23 plus 16 plus 1. The total will be equal to 0.32 gram. So the percent of NaOH in the sample will be its mass divided by the total mass of the sample times 100, which means 0.32 divided by 1 gram times 100, giving 32%. Today, we had our revision on chapter 1 and chapter 2 and some questions of other chapters. So we are going to study them well, and next time we will meet, we will have more questions to be answered. Goodbye. See you next time.